welcome to my YouTube channel. Today we have an Olympiad Math Algebra challenge on the board, and we are going to look at what will be the value of x and y, their possible values. And the question is x plus y equal to 72, and then x to the power of 1/3 plus y to the power of 1/3 equal to 6. So how do we face or solve this kind of question? So let us see. Start by saying solution. We have x plus y equal to 72. Okay, x plus y equal to 72, and then x to the power of 1/3 plus y to the power of 1/3 equal to 6. So what we're going to do is to make the solution easier. What we're going to say is to say let a equal to let's say we put it this way, let x to the power of 1/3 equal to a, and b, and let y to the power of 1/3 equal to b. So from here we're going to get x to be equal to a to the power of 3. How we do that is by simply taking the cube of both sides here. So this will give me 3 will go with 3. So we have x to equal to a to the power of 3. And same way we take the cube of both sides here, and then the 3 and 3 will cancel out each other, and then we have y to equal to b to the power of 3. Okay, so now what happens is that this equation will change. These two equations will change. So what we are going to have is that for the first equation, we are going to have a cubed plus b cubed equal to 72. Let's label this as equation 1. Okay? And then the second equation will become, because we said that x to the power of 1/3 will be equal to a, so we have a plus b equal to 6. Let's call this equation 2. Now we start from equation 1. Let's go with equation 1. Let's start from equation 1. We know that there's an identity we're going to use. We have this identity, an algebraic identity. A cubed, recall that a cubed plus b cubed will be equal to a plus b cubed minus 3ab open bracket a plus b. This identity is very, very important. A cubed plus b cubed equal to a plus b all cubed minus 3ab into a plus b. So that means equation 1. So that means that equation 1 becomes a plus b cubed minus 3ab open bracket a plus b equal to 72. But we know that a plus b is equal to 6, but a plus b equal to 6. This is from equation 2. From equation 2. From equation 2, a plus b equal to 6. So where we see a plus b, we simply substitute 6 there. So we have 6 cubed, means that the equation becomes 6 cubed minus 3ab into 6 equal to 72. So what we are going to do is that I'm going to divide all through by 6 first. Divide it by 6, divide this by 6, and divide it by 6. So we have 6 squared minus to, I think, 12. Okay? I will go ahead again and divide. Okay, what I'm going to do is to say 36 minus 3ab equal to 12. So I can divide by 3 again. Divide 2 through by 3. So this will give us 12 minus ab equal to 4. So we have from here minus ab equal to 4 minus 12. So minus ab equal to minus 8. So ab equal to 8. So we can call this equation 3. So from equation 3, we can say, let's say we want to find b first. A first. We say b will be equal to 8 over a. B equal to 8 over a. Now, let's substitute the value of b into equation 2. Let's substitute the value of b into equation 2. So equation 2 is from equation 2, or let's say using equation 2, which is a plus b equal to 6. A plus b equal to 6. But b is 8 over a. So whenever we see b, we put 8 over a. So we have a plus 8 over a equal to 6. So we multiply each term by the denominator a. So we have a times a plus a times 8 over a equal to a times 6. So we have a squared plus 8 equal to 6a. So this is bringing us to quadratic. So we have a squared minus 6a plus 8 equal to 0. So we solve for a. Let's solve for a. So from here, a squared minus 2a minus 4a plus 8 is equal to 0. How did I get this? It's easy. Just find 2 factors of 8. What are the 2 factors of 8? They are 2 and 4, and then it could also be minus 2 and minus 4. 2 factors of 8 that when multiplied will give us 8, and then when added will give us minus 6. We all know that 2 multiplied by 4 will give us 8. Minus 2 multiplied by minus 4 will also give us 8. Okay? So, and then what we have in the middle is minus 6. So we go for the second set of factors. Minus 4 and minus 2. And that was why we got this part. So what I'm going to do now is to group and factorize. So from this, we have a to be common. Then inside the bracket we have a minus 2. Then from here we have minus 4. Then a minus 2 inside the bracket, all equal to 0. So I'm going to have a minus 2 times a minus 4 equal to 0. So this will give, so we know that if we have a dot b to be equal to 0, then a equal to 0 or b equal to 0 or both equal to 0. So in that case, I have a minus 2 equal to 0 or a minus 4 equal to 0. So this will give us a equal to 2 or a equal to 4. Now if this is the case, so there are 2 values for equal to 4. So there are 2 values for a. Definitely there will also be 2 values for b. Now, for these 2 values of a, let's determine the values of x and y. So we call this the case 1, okay? Case 1. So this is our case 1. Case 1. We have a equal to 4 and a equal to call it a equal to 2 and a equal to 4. So don't forget what we agreed that a should be x to the power of x should be a to the power of 3. So for case 1, a should be equal to x to the power of 3. So if that's the case, then if a equal to 2, that means x cubed should be equal to, x should be equal to a to the power of 3. Sorry about that, I mix up there. X should be equal to a to the power of 3. So that means x will be, this will be x1. We have 2 to the power of 3, which is 8. Then for x2, 8 to the power of 3. So x2 will give us 4 to the power of 3, that is 64. Therefore, x1 is 8 and x2 is 64. That is for the value of a. Now let's also find for the value of b. Now let's go back to our equation. A plus b equal to 6. This is for case 2 now. Case 2. This is for case 2. So when a equals to a equal to 2, b will be equal to 6 minus 2, and then b will be equal to 4. When a equal to 4, b will be equal to 6 minus 4. So that means b will be equal to 2. Therefore, our case 2 now, case 2 will be b equal to 2 and b equal to 4. So, if that's the case, then we have y1. I hope we have y1 to be b to the power of 3. So that will give us 2 to the power of 3, which is 8. Then y2 will be b to the power of 3, and in this case, b equals to 4. So that will be 4 to the power of 3, which is 64. So finally now, for the two cases, we have x1 equal to 8 and x2 equal to 64. And then of course we have, this is for case 1 and this is for case 2. So we have for case 2, y1 will be 64, I think. Is that not? The y1 will be 8 and y2 will be 64. So that's what we're, so we can check this out by looking at the equation. We can check this out. We have x plus y equal to 72. So if we pick x1, so we have, you pick the first value of x and the first value of y. Okay. Oh no. Y plus. Okay, so what we're going to do is to get it, we pick x1, y2. So we have x1 and y2. x1 will combine with y2, and then x2 will combine with y1. So that is how we are going to check it. So for this first one, so we have x1 plus y2, that will give us 8 plus 64, that is 72. Then for this, we have x2 plus y1, that will give us 64 plus 8, which is 72. So that is how we solve the problem. Thank you very much. If you are just today is your first time coming across my channel, please subscribe and give me a thumbs up, and I will see you in the next video. If you are a returning subscriber, please like the video and then share it and then give me a comment. See you in the next video.